Okay, so yesterday, sorry. Pardon me? There is one in the Google Classroom. The notes back in there. That's where we're working. Okay, so you get the invite for the classroom? Just go in there, that's where we're working. Okay, so we ended off looking at how to name binary ionic compounds, which is review from Science 9. Okay, so just a quick review of what we talked about yesterday. When I'm naming a simple or binary ionic compound, I name the metal first, exactly as it appears on the periodic table. Okay, and then I name the nonmetal, and I change the nonmetal's ending to "ide." Okay, it's as simple as that. I don't use any prefixes in an ionic compound because there's only one way that metal and that nonmetal can go together where their electrons will balance out. All right, so when we looked at these ones yesterday, okay, we named them quickly at the end of class. This was sodium chloride, okay, sodium being the metal, chlorine being the nonmetal, so I changed it to "ide." Okay, KF was potassium fluoride. Okay, so potassium and fluorine, and I changed the nonmetal, fluorine's ending to "ide." Okay, for number 3, okay, sometimes when hydrogen is involved, it can be a bit confusing. Okay, hydrogen is a gas. It's also a metal. Okay, because hydrogen is the simplest element, it's kind of the exception to every rule. Okay, kind of like water is the exception to every rule. Okay, hydrogen is the exception to every rule because for hydrogen, it's just as easy for it to gain 1 electron as it is for it to lose 1 electron. So it actually behaves as both a metal and a nonmetal. And it does so pretty much 50-50. Okay, how do I know if hydrogen is acting as a metal in an ionic compound?
It comes first.
It comes first. Metals are always listed first. So if hydrogen's listed first, it's behaving as a metal. That's what's happening in this compound. Hydrogen's first, so this would be hydrogen iodide. Okay, if I had a compound like this, not that it would exist, but let's just say it did. Actually, that would be a terrible one. The only time hydrogen would be acting as a non-metal would be in a molecular compound. Okay, and we haven't talked about naming molecular compounds yet, so I'll get into that later. But if hydrogen is not first, it's behaving as a non-metal, and then it would have its ending changed to "ide," and it would be hydride. Okay, in this case, it's the metal, so I don't change it. All right, for number 4, I've got calcium acting as my metal, bromine acting as my nonmetal, so I change its ending to "ide." Okay, is that ringing a bell? All right. Then, just for the sake of review and practice, I want you guys to write the names of those 6 compounds using your periodic table. Okay, let's look at maybe the first 3 here, just in case there's some people that still aren't done. Okay, so number 5, what's Al? Aluminum. Oh, and I wrote it as a capital. We are not supposed to capitalize. So aluminum, and then At stands for astatine. Okay, but we have to change that to astatide. So this will be aluminum astatide. Okay, and if you feel like I'm not pronouncing that right, I won't pronounce it the way it's written, okay, on the periodic table. The International Union of Physics and Applied Chemistry officially changed the pronunciation of aluminum to aluminium, which just sounds dumb, so I won't do it. Okay? And I'm sure most of you say it aluminum too. It's kind of the North American way, okay, versus the European way to say it, which is aluminium, which just doesn't sound right. Okay? I don't drive an all aluminium truck. I don't drink out of an aluminium can. Okay? It just doesn't sound right. Okay? So it won't say it or write it that way. Feel free to do it whichever way. It won't bother me. Okay. All right. For number 6, what does CS stand for? Cesium. Okay, so that's our metal, so we don't change the writing of its name, and it is with S, which stands for sulfur, so cesium sulfide. Okay, and for number 7, Na is sodium. That's our metal, and it's with oxygen, so sodium oxide. Okay, how many people have done 8? So for number 8, okay, Ba stands for barium. Okay, that's our metal, and then Se is selenium. Okay, so you can actually write selenium a couple of different ways. Some people write it selenide. That's the way I write it. It can also be written selenamide. Either way is correct. Okay. I write it selenide because it's shorter. All right, number 9. So if we're looking at number 9, Ra stands for radium. Okay, Te stands for telluride, or tellurium, so this would be telluride. Okay. And number 10, Li is lithium, that's our metal, so we don't change its name, and it's with fluorine. Fluoride. Questions on any of those? Okay. Now, according to the rules we've been following, okay, we're supposed to name the metal first, the non-metal second, not change the name, don't use any prefixes, okay, etc. So, let me present something to you. Those are both ionic compounds. What are their names? Cu stands for copper. O stands for? Okay, so this is copper oxide. What's this? Is that a problem? Yeah. It's like two people who are obviously different having the same name, which has happened to me. I once had 2 Chase William Andersons in the same class. They were not the same person. In fact, no 2 people could have been more different. But they had exactly the same name. I sure hope I didn't screw up their marks at any point during that semester. Okay? So, is this a problem? This is a big problem. These 2 chemical compounds are not the same. Okay? Now, I'm not saying that this is true, but this one could be completely inert, and this one could be highly poisonous. And if I'm reading an article about the health benefits of copper oxide and I decide I'm going to drink some, I might drink the wrong one and die. That's a problem. Okay? I can't have 2 things that are different have the same name. Okay? So, when it comes to certain metals, we have to add something into the names of their ionic compounds. Okay? On your periodic table, you will find that some of the transition metals, that's the metals in the middle, okay, have more than one possible charge. Okay, if you're looking at the periodic table, and you're looking at copper, for example, okay, up here in the top right corner, I believe, you will see a +2 and then a +1, or is it +1 and then +2? Right, +2 and, no. +2 and +1. Okay. This means that copper, as a metal, sometimes gives off 2 electrons, and sometimes only gives off 1 electron, which means it can get into chemical compounds in different ways. And if I don't have a way to tell people that this compound has 2 copper in it, and this compound only has 1, they're going to get confused. Everybody follow me there? Okay, so anytime you're making a chemical compound, okay, or writing the name of a chemical compound that has more than 1 possible charge, you have to put in a Roman numeral in the name to tell them which charge of copper or which charge of iron or whichever other metal that does it, okay, is being used. So, the first thing you have to do is figure out which charge that particular copper has. Okay, it can be a 2 or a 1. So if I'm looking at this compound right here, okay, I need to figure out which charge copper has. Now, what charge does oxygen have? -2. Yeah. Okay. We always look at the non-metal. There are no non-metals that have more than one possible charge. Okay. All non-metals have only one possible charge. So this oxygen has a charge of -2. Now, in an ionic compound, all the charges are supposed to balance out, right? The overall charge is supposed to be 0 because oxygen's going to take 2 electrons from whatever it's with. So, what charge does the copper have? +2. Okay, so all I've done is check which charge it has using the non-metal it's attached to. So this stuff would be written as copper, Roman numeral 2, oxide. Okay. Now, for the other compound, okay, oxygen still only has a charge, or always has a charge of -2. In this case, there are 2 coppers. And if I'm going to have an overall charge of 0, that means each one of these coppers only has a charge of 1. Okay, so this stuff would be written as copper 1 oxide. Question? Pardon me? Yes. Okay, is that sort of making sense? Okay, so now we don't have this problem anymore. When I write the name of those 2 compounds, people will know which one I'm talking about. Okay, because I put a Roman numeral in, okay, that denotes which one is which. Okay, is it really hard to figure out what the charge is? We're just trying to make it so that the same number of negatives and positives. Okay, really easy. All right, does everyone know the Roman numerals? Yeah? Some people are not so sure. Okay, you guys are the generation of the reboot. My generation was the generation of the sequel. Okay, like Rocky 2, Rocky 3, Rocky 4, Rocky 5, Rocky 6. Well, it wasn't Rocky 6, it was Rocky Balboa. But okay, we had Roman numerals on everything. Okay, if you ever watched the Super Bowl, like some people can't even tell what the number is. There's so many freaking letters because they use the Roman numerals, okay, for the Super Bowl numbers. Okay, so we're only going to need to know up to like 5. Right, so here's how the Roman numerals work. 1, 2, 3. That's where the pattern ends. Okay. 4. IV is 4 because it's 1 less than 5 because 5 is V. That means 6 is VI, and 7 would be VII, and 8 would be VIII, okay? And then 9 is 1 less than 10, and 10 would be X. Again, you're not going to need to know beyond 5, okay? There's like only one thing that has a charge of more than 5, okay? And we just don't use it. All right, so those are your Roman numerals. If you know up to 5, you're good. Okay? This is why the Roman Empire fell. Okay? Their numbers made no sense. People couldn't count. All right, questions on what we did there? All right, so this is kind of the notes on that, okay? If we're looking at the transition metals, or what we call multivalent metals, we call them multivalent because their outer shell gives off different numbers of electrons, okay? So most transition metals have several possible charges, okay? And that has to be shown when you're naming compounds. So to do that, we use a Roman numeral to denote which form of the metal was used. So copper 2 sulfate would be an example, okay? Or iron 2 oxide. Okay, now, how did I know that this iron had a 2 charge? Right,
because oxygen has a -2 charge. Okay, there's one oxygen here, it's -2. There's one iron here, it's got to be +2. Okay, if there were 2 irons there, then the iron would only have a charge of 1. Okay, everybody okay with that? What would this one be? Iron's 2 possible charges are +2 and +3. And 1, 2, and that's 2 and 3. Okay? Okay, here's how we do this. You might want to write this one down as an example of a trickier one. We've only done like the super, super easy ones. Okay. Every oxygen has a charge of -2. How many oxygen atoms do I have in this compound? 3. Okay, so if every oxygen is a -2, and I have 3 oxygens, how many negative charges in total do I have? 6. Okay, so I take this number, the charge, and I multiply it by the number of that atom. That means there are 6 negatives here. So that means there has to be 6 positives to come from the iron. Agreed? Because this has to balance out. It has to have a charge of 0 overall. That would be the same number of negatives and positives. So I've got to get 6 positive charges out of 2 irons. 6 divided by 2 is 3. That means this iron has a +3 charge. So you got to do a little bit of math, but it's pretty easy math. Okay, you just got to divide numbers. Okay, multiply numbers, simple stuff. Okay, so this stuff here would be iron, Roman numeral 3, oxide. Okay, whereas this stuff is iron 2 oxide. That's something you wouldn't have done in Science 9. That's new. Okay, you wouldn't have done any multivalent metals in Science 9. Okay, so we just did number 1, so we don't have to worry about doing that. Okay, I want you guys to try 2, 3, and 4. They all are going to need Roman numerals. Okay, so what you need to do is look on your periodic table and see what the possible charges are, what the charge on the nonmetal is, and see if you can figure out what Roman numeral should go in the name. Okay, the naming rules still work the same. Metal first, nonmetal ends in I, but we got to put a Roman numeral in between. All right, so for number 2, CO stands for cobalt. Okay, and S stands for sulfur. Okay, so this is going to be cobalt something. We're going to have a Roman numeral in there, sulfide. Okay, now, sulfur always has a charge of -2. Okay, there's only one sulfur and there's only one cobalt. So the charge on cobalt must be +2. It's got to be the same, right? They got to cancel each other out and add up to 0. Okay, so this is very simply cobalt, Roman numeral 2, sulfide. Okay, is 2 one of the possible charges for cobalt? All right, for number 3, we've got Mn, which is manganese, and we've got chlorine. So this is going to be manganese something chloride. Okay, what's the charge on chlorine? -1. How many chlorines are there? 4. So how many negative charges do I have here? Right, I've got 4 negative charges. Okay, so that means I've got to get 4 positive charges out of 1 manganese atom. So what's the charge on that atom? one of the possible charges for manganese? Okay, so manganese, IV, okay, chloride. Okay, we've already done one with copper, so okay, Cu is copper, okay, and S is sulfur, so some copper sulfide, okay, and just like this one, sulfur is always a -2. Since there's only one of each, the charge on the copper must be +2. Copper to sulfide. Everybody all right with that? Okay, I want you to try a few more here. Okay, give you a few minutes on those and then we'll walk through them together. Okay, so for 5 and 6, okay, so for number 5, SN stands for tin. Okay, and TE stands for tellurium, so this will be tin something telluride, right, because I changed the ending of the nonmetal to I. All right, what's the charge on telluride? Telluride's always a -2, right? Okay, how many telluriums are there here? 2. Okay, so -2 times 2 gives me a total of 4 negative charges that need to be balanced by this tin atom. Okay, so this single tin atom has to have a charge of 4. Okay. So this will be tin, Roman numeral 4, telluride. Okay, questions on 5? Okay, so for number 6, okay, Hg stands for mercury. And At is astatine, so this will be mercury something astatide. Okay. Charge on astatine is always -1. And there are how many astatines? 2. Okay, so how many negative charges are there? 2. Okay, so if there's 2 negative charges, then there have to be 2 positive charges. Since there's only one mercury atom to do that, the charge on that mercury atom must be +2. Okay, how many people have done 7? Okay, let's have a look at 7 then. Okay, so for number 7, we've got PO, which stands for polonium. Okay, and I stands for iodine, so this will be polonium something iodide. Charge on iodine is always -1, and there are 4 iodines, giving us 4 negative charges. That means there have to be 4 positive charges from the polonium. There's only one polonium here, so the charge on it must be 4. Okay. All right, I'll give you a few more minutes to do the last 3 and then we'll walk through those together. Okay, so for number 8, okay, SB stands for antimony. Okay, and S stands for sulfur, so this is going to be antimony something sulfide. Okay, so this is one of the trickier ones because there's a couple of numbers here. All right, what's the charge on sulfur all the time? -2. Okay, how many sulfurs are there? 3. So there's how many negative charges? 6. Okay, so I've got 6 negative charges. That means I've got to get 6 positive charges from 2 antimony atoms. So what's the charge on each antimony atom? 3. Okay, just 6 divided by 2. Okay, antimony 3 sulfur. All right, number 9 works very similar to that. Okay, so we've got Ni, which is nickel. Okay, and N, which is nitrogen, which gets abbreviated nitride. Okay, what's the charge on nitrogen? -3. And there are 2 nitrogens for a total of 6 negative charges. So I've got to get 6 positive charges from 3 nickel atoms. 6 divided by 3 is 2. So this is nickel 2 nitrogen. Okay, and then for number 10, okay, we've got ruthenium, okay, and oxygen, so this will be ruthenium oxide. Okay, every oxygen is -2, and there are 2 of them, so that's 4 negatives. So that means the charge on ruthenium must be okay. Everybody all right with that? No?
Because ruthenium only has a +3 charge.
Yeah, I made this with the old periodic table, I changed it. Yeah, the old periodic table had 3 and 4. Yeah. And something else, another 3. So, yeah.
Oh, that's the issue.
Yeah. So that's my bad, sorry, I should change that because it gave you, this is a new periodic table. Okay. So, good catch.
So should we rank the +4?
No, don't. It's just, it's a mistake on my part for not changing it back. All right. Any other questions on how that works? Okay. Now, what if I have something that looks like this? This is something else you wouldn't have done in Science 9. How would I name that? Because now it's not 2 elements, there's 3 elements here.
Sodium, oxygen, hydrogen?
Okay, and that's what I would expect you to say because you've never seen one like this. You go, well, I'll just name them all. Okay, it's sodium, it's oxygen, hydrogen's last, sodium, oxygen, hydride. I would expect that that's what you do, try to adapt the rules that we know, okay, to this. However, what's going on here is a special kind of ionic compound. We've got a metal and then what we call a polyatomic ion. Okay, poly meaning many, okay, atom meaning atomic meaning atom, so many atoms. So this is a single ion made of 2 or more atoms, polyatomic. If you look at the top of your periodic table on the left-hand side, there's a table of common polyatomic ions. Okay, in there are all the weird polyatomic ions that are common. Okay, and you'll see that OH is listed in there. Okay, and it's called, right, that's, OH is called hydroxide. So this stuff would be sodium hydroxide. Okay, naming ionic compounds that have polyatomic ions in them is actually easier than doing the Roman numerals. You just have to look up the name and write it exactly as it appears in the table. Okay, don't change the ending, it's already been changed. Okay, all you have to do is go metal and whatever the name that's written in that table is, you're done. Question?
Are we gonna be allowed to have our table like for tests?
Oh, yes. Yeah, this is actually the one that's in the diploma exam data booklet. Okay, so if they'll let you have one on the diploma exam, it would be pretty shameful if I didn't let you have one in science. Okay, so yes, you can have your periodic table out for quizzes and your unit exam. On the final exam, I give you a fresh one because usually by then people have lost them or written so much stuff on it, it's like a cheat sheet. Okay, so yeah, you'll always have one. Okay, so what would this stuff be called?
Copper sulfide?
Okay, close. It is copper something sulfate. What do I have to remember about copper?
Roman numeral 2.
Right, it needs a Roman numeral. Okay, how do I know that? Well, every time I write the name of an ionic compound, I need to check the periodic table to see if it has more than one charge. If there's more than one number in that top right corner, then I gotta put a Roman numeral in there, okay? Sulfate on your chart is written as a -2, okay? And there's how many sulfates here? 1. Okay, that can be confusing, that's why I did this, okay? Sulfate is SO4, okay? There's 4 oxygens and 1 sulfur, but the sulfate, the whole thing, has a charge of -2. Treat it like it's an element, it's not gonna come apart, okay? So if it's got a charge of -2, okay, and there's only 1 sulfate, okay, then copper must have a charge of +2. Okay, so you'd know if there was more than one of these because they'll be in brackets, which I'll show you next. Okay, so we could have something like this. Okay, what's Ca stand for? Calcium. Okay, and what does NO3 stand for? Nitrate. Okay, this stuff is calcium nitrate. Doesn't matter if there's brackets, doesn't matter if there's 2, okay? I don't change any of my naming, I don't put in any prefixes. Right? If this was a metal that needed Roman numerals, then I would obviously have to figure out which Roman numerals it would need, okay? And it would be like, this is a -1, but there's 2 of them, and I would go back and do the same thing with others. Okay, everybody all right with those? Okay, so here's the challenge. Every time we've dealt with something in terms of naming, all the questions I've given you were for that idea. What if I just give you a mix? Some of them have polyatomic, some of them need Roman numerals, some of them don't, okay? Are you gonna be able to figure out which ones need Roman numerals, which ones don't? Okay, you're gonna have to. How can we tell?
If it needs Roman numerals, it'll have more than one kind of charge.
Exactly, okay? If it needs Roman numerals, it'll have more than one charge in the top right corner. If it doesn't, it'll only have 1. Okay, it could be a +1, could be a +2, could be a +3, but it'll only have 1 charge. Okay? Everyone all right with that idea? So it's something you have to watch for because it's easy to forget. Thought I had a mix of them somewhere. I guess I don't. Okay, before we get to molecular compounds, I want to look at going the other way. Okay? I've been giving you the formula and saying, write the name. We got to be able to go the other way too. I give you the name and you write the formula. Okay? This is where that whole thing about the drop and swap and drop whichever way, ends up being the same either way. You guys heard that before? The drop and swap? That seems new to some people. Okay. So let's say I give you this name. And I want you to write the formula for that. Okay? Here's what I do. What's the symbol for magnesium? Mg. Okay. What's the charge on magnesium? +2. Okay. What's the symbol for iodine? I. What's the charge on iodine? -1. Okay. Here's where I do the drop and swap. Okay? When I write an ionic compound, I need to make sure that there's the same number of positives and negative charges, right? It has to add up to 0. Right? All the electrons have to work out. So if I've got a magnesium with 2 positives and iodine only has 1 negative, I'm going to need how many iodines? 2. Okay, so here's how we always get the right number. drop the charge and swap it. Drop the charge and swap it. We just don't write ones in a formula. MgI2. Okay, that's how we write the formulas for all ionic compounds. And it works no matter what. Okay, works whether there's a polyatomic ion, works if it needs a Roman numeral. Okay, in fact, if it needs a Roman numeral, it'll look like this. So we'll have okay, so I've got iron 3 sulfide. What's the symbol for iron? Fe. Okay. What are the possible charges for iron? 3 and 2. Which one am I using? 3, because the Roman numeral 3 is there. That's what the Roman numeral is for. It tells me this is the iron with the 3 plus charge. Okay, symbol for sulfur, S. Charge on sulfur, -2. Drop, swap. Drop, swap. Done. Okay. Am I right with that? Okay. How many people recognize that from before? Drop, swap. Okay. All right, what if I had this one? All right, so symbol for calcium is Ca. Charge on calcium is +2. Okay, what's hydroxide? OH, right, it's a polyatomic ion. Okay, what's the charge on hydroxide? -1. Okay, so there's a little bit of a special rule here for this one. Okay, if I drop and swap this like I've done all the others, I'm going to end up with this. Okay, that's not right. It's saying there's 1 calcium, 1 oxygen, and 2 hydrogens, when in fact, I want it to say that there are 2 hydroxides. That's 2 oxygens and 2 hydrogens. That's different. Okay, so when we're dealing with a polyatomic ion, it always stays together. We don't separate it. Okay, so if we have to put a number beside it, we have to enclose it in brackets. Okay, it becomes even more confusing if I have something like this. Okay, the charge on nitrate is -1. The charge on calcium is +2. If I just drop and swap, it looks like this. That's 1 calcium, 1 nitrogen, and 32 oxygens. That is much different than 2 nitrates. Agreed? Okay, so we've got to put brackets around things if we've got to put a number beside polyatomic ions. There. Okay? Everybody all right with that? Don't worry, this is not like the only day we're going to do this. Okay, I recognize that some of these things are new. We're going to have some time to practice this stuff. Okay? But there's lots of little rules that you didn't get taught in science now. All right, does everyone understand the drop and swap? Okay, so there's one other thing that can happen sometimes with the drop and swap, and it would be in a situation like this. Okay, so let's say I've got lead 4 oxide. And if I'm going to write the formula for this, lead is Pd. Okay, and the 4 tells me it's got a 4 plus charge, because lead can be 2 or 4. And oxygen is always a negative 2. Okay, so now when I drop and swap, I'm going to get 2 and 4. Okay, that balances my charges, but ionic compounds are like fractions. If I can reduce them, I should. Okay, because I wouldn't have to have 2 leads and 4 oxygens. I could have 1 lead and 2 oxygens, and my charges would still be balanced. Okay, so I always want to make sure my ionic compounds are in the lowest terms. It doesn't happen very often, but it is something you have to be on the lookout for. Okay, so the charges still work here, because this is a plus 4, this is a minus 2, right? 4 times 1 is 4, 2 times 2 is 4, so it still works. Okay, it's just in the lowest term. Okay, I'm going to write a couple more up here and just have you guys try them. See if you can remember the rules here. Quick look at these here just before class ends. Okay, so I got magnesium oxide, so that's going to be Mg, which is a 2 plus. Okay, oxygen, which is a minus 2. Okay, so we got 2 and 2. All right, would I write 2 and 2, or would I just leave it as 1 and 1? Yeah, leave it as 1 and 1. This already balances out to 0. I don't need to write more numbers. Okay, I just leave this as MgO. Okay, sodium sulfide, Na is a plus 1, sulfur is a minus 2, so the 2 goes here, the 1 goes there, Na2S, okay, we don't write the 1s. For lithium carbonate, lithium is Li, it's a plus 1, carbonate is CO3, and it's a minus 2. Okay, so when I drop and swap, the 1 would go here, we don't write 1s, so I don't need to do that, okay, and the 2 would go here. In this case, I don't need brackets because I'm not putting a number beside the carbonates. Okay, I would need brackets if a number was going beside the 3, but it's not. Okay, and then lastly, nickel 2 nitrate. So nickel is a plus 2. Nitrate is a minus 1. So the 1 would go here, and the 2 would go here, which means that would need to be enclosed in brackets. Alright, we're going to work on that some more tomorrow and probably a bit on Monday as well. Okay? Alright, good work today, guys. I'll have you mask up and pack up so I can come around and wipe down your desks.